Bismillahirrahmanirrahim. Assalamualaikum warahmatullah. This video will be part 13 of my SolidWorks mini vacuum cleaner project. In my previous video, I have already shown you how I have done this assembly drawing and also the exploded view drawing. Okay, I just need to tell you that this exploded view, I have changed the orientation of the view of this my mini vacuum cleaner. I already make a different view at this isometric view, and I have rearranged my balloons. Right, so in this video I would like to show you how I will do the detailed drawing of all the parts involved in making this mini vacuum cleaner. Since you have to produce a set of working drawings, a set of working drawings of a product mean you have a set of assembly drawing, where a set of assembly drawing you have assembly drawing plus the exploded view drawing together with a set of detailed drawing of each part that involved in making this product, except the standard part like DC motor, the rechargeable battery, and the PCB, and also the screw M1.5, since those parts are standard components. Alright, in this video I would like to show you, I cannot show every parts for detail drawing, so I will show you the main part first. The main part will be the rear casing and also the front casing. So in this video I would like to show you how I will do detail drawing of this rear casing and also front casing. Okay, to do the detailed drawing of the rear casing, so I will go back to the assembly file. So this is my assembly file. This is an exploded view, my assembly file. So I will click at the rear casing and I go open part. Alright, to do the detailed drawing of this rear casing, I will not go to make a new drawing from here, since I have already the drawing file from my set of assembly drawing and also exploded view drawing that I've shown you before. So I just remain this part file of this rear casing open. Then I go back to the drawing that I've done for this assembly and exploded view. Okay, to do the detailed drawing of this front rear casing, so here at the bottom here I will not click at add sheet. This is okay, but I think I have to retype my name and my particulars here, so I will delete it. One way to do it is that I will make a clone version of this assembly drawing sheet here, so I can make a copy and I will paste it. Okay, I just after selected sheet and I just click yes, and here the assembly drawing tool, I will drag it. So assembly drawing tool is a clone version, so I can simply delete this thing, all the viewport and also the BOM as well. Okay, since this is the detailed drawing of the rear casing, I rename it as rear casing. Okay, also about the title block, I will edit it, and this one I will name it as rear casing. Okay, rear casing. For the material, if you look at the assembly drawing, the rear casing material is ABS. Right, to put the text here under annotation, we have text, and I put it here. Make sure in capital letter ABS, and about the drawing number, since for if you look at the BOM, the drawing number here, I will type 1 for the assembly drawing in the BOM. So rear casing will be drawing number 1, and here for the rear casing I will double click at this drawing 1. And about the scale, later I will adjust it, either I will use half scale or full scale. Make sure all your particulars is there, and also this rear casing is orthographic drawing. It could be sectioning, but we must have the third angle projection symbol. Okay, now I go back to the drawing mode. I save my file again. Okay, now I will show you how I will do the detail drawing of the rear casing. Okay, to do the detail drawing of the rear casing, at the right here we have menu view palette. I click at view palette. Now I have all the view. So the rear casing is listed here since I have already opened the rear casing file. If my rear casing file is not open, I close it, and when I go to view palette, if your rear casing is not showing here, you have to click at browse and you search for your rear casing file. So this is my rear casing. That's one way to do it. And now SolidWorks will put all the menu in the menu here, all the possible views from the rear casing part modeling file that we can drag into this drawing. Okay, before I proceed putting all the possible views for me to create the detailed drawing of this rear casing, let me show you the first thing about this rear casing of this mini vacuum cleaner. Alright, as you can see, this is a part modeling that I've done for the rear casing, and this rear casing is a plastic part made from ABS. As you can see, it have kind of like a complex internal and also external features. As you can see, in the internal side we have internal feature like ribs, mounting bosses for the fastener, and also we have a supporting rib to hold the DC motor, the rib to hold the battery, and also the slot to hold the PCB. So I think to do the detailed drawing with detailed dimension, it would be too complex to be shown. So I think it's not necessary to show really detailed and complete dimension for this kind of plastic part. So I will only include the important dimension such as the overall size and the features which is important for assembly and fit in engineering drawing. Another thing to mention that the way they manufacture this rear casing is meant to be produced the way they manufacture it by using injection molding machine. The 3D model here is your CAD file. So this 3D model, the CAD file from SolidWorks, will be sent to CAM software, like for example Mastercam. So that Mastercam will generate CNC program for making the metal mold, and that metal mold is then will be sent to the injection molding machine, where in that injection molding machine the liquid ABS plastic is injected to form the rear casing. Alright, since we have the metal mold in that injection molding, so that's how they make these rear casings. So we don't have to put really detailed dimensions. So the main goal of this detailed drawing of this rear casing is just to show the design intent and assembly. So we don't have to produce really detailed dimensions. Okay, to do the detailed drawing of this rear casing, the first things I need to decide which view that I should drag to this drawing. For my case, is the rear casing. With the most important view that I should put into this drawing will be the front view. So I will select this front view and I will drag it to this position. If I bring my mouse here, I can go for plan view, and I bring here, I can go for left view. If I bring here, it will go for isometric view. So I press escape, and okay, as you can see here, this main view is the front view. If I click at it, because there is 1, 2, if I go for 1, 1 full scale, and let me drag this thing. So I think full scale is good enough to be fit into this A3 size paper. And about the isometric view, I put it here and I make it shaded style, and also right click at it, I make the tangent edge remove. And also this isometric view, if you look the setting on the left, make the half scale. Alright, since I already put 3 views here, later I will decide which view I can delete, either the left view or the plan view, but I need this front view, since the front view is the main view, because the front view can showing all the features of this rear casing. Okay, let me delete for a while this left view and also the plan view, since I already mentioned that we don't have to do complete detail dimension for this rear casing, and I will show only basic dimension like the overall size and dimension for important features of this rear casing. Alright, about this front view, later also I will show you how I will do the remove section, not full section, that could show some features of this rear casing. For example, the ribs, the holes here, we have the hole for the power button, and also features of the slot, and also features of the, we have 3, 4, 5 pins here, and the other important features. Alright, the first thing is you look at this 4 pin here. We have center mark. If I click at that center mark, there is a center mark. It's use the document default, so I uncheck it. I make sure I put it 1. It's kind of like, now we have better version of center mark, so here as well. So I will select this center mark. I select this one also. Then I uncheck it and make it the size is 1. Right, let me save my file first. Okay, since this front casing is not a section view, so they will be a typical orthographic view, so I will make sure it show hidden line. And another thing, I got to make sure that the tangent edge is removed. Okay, I need to show, because this is handle, I need to show a center line, since the handle is kind of like a elliptical shape. It's not a round shape, but I need to show the axis. So I have the center line under notation, the center line, so I will select these 2 lines and hold on my control key, then I have the center line, so it kind of like show the axis of this handle, right? Then put it like this. And same goes for the, since the upper part here is like a cylindrical shape, and I will do also center line, so I select this one, and hold on, not this one, let me clear everything. I do center line, I select this line and this line, so I have the center line, so I can drag the center line like this, so we have the axis. Okay, before I do dimensions for this rear casing, I need to mention to you again, this is the rear casing. It is plastic component made from ABS. The way they will manufacture this rear casing is not by reading your drawings. Since this is a plastic casing, the way they manufacture this rear casing is by sending your part modeling file, your SolidWorks part modeling file, to CAM software like Mastercam. And this software will translate your SolidWorks part modeling file into CAM version, and when it in this software, you will do kind of coding, translate it so that this file can be read by CNC machine, and this file will be sent to CNC machine, computer numerical control machine, and this CNC machine will do the right tooling and will make the metal mold for this rear casing. After the metal mold is done by the CNC machine, and this metal mold will be put into the injection molding machine. So in this injection molding machine, it have a feeder, so the operator of that machine will pour the plastic bits, which is ABS material, and in this injection molding, the feeder will be fed into a screw feeder, and the screw feeder will compress these plastic bits into liquid ABS plastic, and this liquid ABS plastic will be injected to the metal mold done by the CNC machine and already put into that injection molding machine. So they make a mass production for this rear casing. So since this is the case how they will manufacture this rear casing, we don't have to put really detailed dimension for this rear casing. As long as the dimension is meant for assembly line, because at the end of the production line the assembly guy will do assemble of your parts, so we need to provide a dimension for a guide for the assembly guy in the production line, where it knows what the dimension in terms of assembly and fitting. For example, like we need to give dimension what will be at the end nozzle of this rear casing. We need to give diameter, since we need to fit the dust container into this position, because the dust container we have the inner diameter, so we will refer to this rear casing what will be this outer diameter here. It's kind of like for assembly and fitting of parts, so you don't have to give detailed dimensions for this rear casing unless your drawing is meant for the machinist at the manufacturing floor to do the machining, like most metal parts. So it means your drawing have to be really detailed, completed dimensions. Alright, so the dimension here will be a rough dimension. It can be the overall size of this rear casing, and also dimension of features for assembly and fitting. Like for example, like I mentioned just now, the diameter of this nozzle to be fitted into the dust container. Then also the position of this pin, because we have bigger pins for these rear casings. We have 5 pins, so we need to give what is the size of this bigger pin. And because since this pin will be fitted onto the front casing, and it will be fit, since the front casing we have a smaller pin, will be fitted onto this bigger pin here. So we need to give the what is the dimension of this pin and the location. And also inside here we have inner thread. We have inner thread because of assembly of fitting of the fastener, the screw M1.5. We need to give what is the dimension for this inner thread, like for example M1.5 for the inner thread. And also features like for example, like I don't have to give what is the thickness of this rib, because that is not significant, like I mentioned just now. The only things about fitting, since for this supporting rib we need to fit the DC motor with impeller need to be fitted at this location. We need to give dimension in terms of fitting the DC motor. For example, the DC motor is cylindrical shape by certain diameter, so we need to give what is the diameter of this cutout, only for assembly and fitting. Also about the battery will be put into this location. Since the battery we have cylindrical diameter, we need to give what is will be the diameter of this cutout of this to where we will mount the rechargeable battery. Also we have a hole here for the power button to be fitted here. We need to give what is the diameter of this hole. And here also we have slot for the, we have PCB, and with the USB port we need to give the what is will be the dimension of this slot, and only the important features only. We don't have to make really a complete detailed dimensions. So I will show you how I will do dimensions for this rear casing. Okay, to do dimension for this rear casing, okay, the first thing about the important features here for assembly and fitting. So what I will do, this diameter at the end nozzle here, since it will be fitted into the inner diameter of the dust container. So for you to do dimension, under annotation we have smart dimension, so I click at smart dimension here, then I will go for this line and this line. As you can see, when you do dimension we have kind of like icon, you want to go to the left or to the right. So I will go to the left, so it will be put at this location. And as you can see, the text is 50.00. so here setting on the left, under tolerance precision I can go for none, no decimal point. Alright, if I click OK, just need to show you the dimension is okay, dimension text is okay, the dimension line is okay, but about the arrowhead is not kind, we don't have a fill in here, a solid. So this is not standard. In order to do that, here option, you click at option, and okay, in the menu here, I'm not going for the tab system option, under document properties, so we have here dimension. Okay, if you look at the settings here, for the, if you look the style of the arrowhead, I will not go for like this, so I will go for the second one. It make a solid arrowhead. So then I click OK. Now you can see the arrowhead is solid. Alright, and okay, I already put dimension 50, but you must obey the standard dimensioning. It's not too far away and not too near, but at least for the first label is 2 letter heights about this position. Okay, if you put sometimes your text is not aligned, your text is not at the center, here the setting on the left here, you go for here under dimension tag, we have here the icon here. If I click it make a center for this dimension text. You put your text at the middle. Alright, okay, another important dimension is about like I mentioned, okay, we have a slot here. We have a slot since we need to fit the rack cap, so at least we can show what will be this diameter of that slot. Alright, so I will give since the rack cap is based on this diameter, so I click at this one and this one, then I can put at this location. Okay, so the diameter is 49. Since the rack cap, the diameter is also 49, will be fitted here. About the decimal point under tolerance precision, here you can go for none, so it makes no decimal point, and you need to position a little bit closer. Right, and another important dimension will be okay, before I go dimensioning the pins, the 5 pins here, is about the overall size of the, because the upper part is more like half cylindrical shape, so I need to give the length here, the overall length, so I can go for here. So I click at this one, I can go to the top position and go for no decimal point, right, and not too far above, about this location. Okay, let me save, hold on, let me save my file. So I have a basic dimension about the overall length of the cylindrical unit. And okay, another about overall dimension is about the what will be the total length of this handle. At least I can show it. Okay, to do the length of this handle, I can do dimension from, okay, to do this I will do start from this point up until not point. I will go for this line, so it can make a line dimension like this. So I click like that, so 85.27 will be the length of this handle. But if you look the setting on the left here, about the, here we have make center dimension, so and you put your dimension tag in the middle. Right, I have the total length. Okay, another thing is about the width of this handle. Alright, the width of the handle, I cannot make a kind, we have a projection view at the bottom here. One way to give the width of this handle, since this handle the shape is not round, is more elliptical shape. Okay, I can do what we call it under drawing, we call it remove section. Okay, to do remove section, I can select this line and also this line. So I have a position where I want to do remove section. I will not do at this section, I will go straight away to the rib, supporting rib that can hold the batteries. So I make sure it snap at that middle point, then I simply click OK. Then I bring my mouse to this location. So this is a remove section. So by this shape of this section view here, I can give what is the overall cross section of this handle. So I can, under notation, I can give dimension from this point to this point. So I can give, hold on, I must click a dimension first. Dimension from hold on, from this point to this point. Make sure it's aligned dimension like this, and setting on the left, I make it no decimal point, and I click OK first, then I drag it somewhere at this position. So this will be the width of the handle. Since this is a elliptical shape, it's not a full round, full circle. Okay, for me to do dimension from this point, if I do the dimension from this point, hold on, from this point to, I don't have a reference point here to do what will be the height of this elliptical shape. So in order to do that, under the sketch here, I can do a point. So I put a point somewhere. It will snap at that middle of this ellipse. So I have a middle point there. So under notation, I can do smart dimension again. So I can start from even this line also, this line up until this point. So I can put we have a width of, I just click OK. Now we have a width of 17.5. So this will be the overall size of the cross-sectional shape of this handle, right? Okay, let me save my file again. Okay, the next one will be, after I've shown here, another thing is about, okay, since we have a features, we need to show what will be the diameter, since we need to mount the rechargeable batteries, because rechargeable batteries it have a diameter. So I need to give this dimension here to show radius or diameter. So this is meant for the assembly and fitting. So I have, it means that the diameter is 8.5. It means the diameter is 19, because since the diameter of the rechargeable battery is 19. Okay, I have that features. And another thing is about, okay, about the we have 3 more supporting rib. I don't need to put, because it's kind of like I don't have to put detailed dimension. At this dimension that I want to show only for meant for assembly and fitting. So once I already put here, it's kind of like enough to show. So we have a supporting rib here, and the diameter is 16, and it's meant to we put the rechargeable battery at this supporting rib. Right, like I mentioned, another thing is about maybe I can go for the overall diameter. So since here is meant for the cutting slot, we have a cutout for the rack cap, but at least I can give what will be the diameter for this cylindrical unit from here to this one. So I can go to the right, so it give diameter 55. This one I make it no decimal point. Okay, so I have that diameter. I already given the overall length. And okay, another thing is about these 4 pins. I need to give the location of these 4 pins. Okay, another thing about this pin also, I forgot to put the center mark. So under annotation, we have center mark. I will select this circle. So I have that center mark. This one I don't want to use document default size. I will go for 1. So I have a kind like a standard size for the center mark. Now I will give dimension, the position from this center marks to this center mark. So I just click at the upper icon. As you can see, automatically the diameter 68 will be shifted upward. I need to drag it, so this 40 need to be a little bit closer like this, and no decimal point, and the diameter 68 need to be a little bit like this. Alright, so I have the dimension, the distance between these 2 pins, and also what will be the vertical dimension, the distance between these center marks and these center marks. So I just bring the icon to the right, so everything is shifted, and no decimal point, but I need to readjust. Not, it means that the dimension is not too far away to the right about this location. I need to adjust this thing, make it a little bit closer. Okay, then I click OK. Hold on, then I save my file again. Right, I already give the horizontal dimension and vertical dimension of the pins. So where is the position from this center point of this pin to the end here? So I need to give the location from here to here. The dimension is 18. Here 18, you have to make it align like this. You have to make it align and no decimal point. Alright, no decimal point. So now I have 18. Okay, since I already put the location of the 4 pins here, and I need to give what will be the diameter of that pin. So I can do it like this. I can give here the diameter. Even sometimes it's allowed to put your dimension inside, but because in terms of clarity, maybe I can put it 6. So you have diameter. no decimal point. So this will be the size of the pin, and also I need to give what will be the inner diameter. So inner diameter, since this inner diameter will be fitted into the pin of the front casing, will be fitted into this inner diameter. So at least I must show also the inner diameter, so I can go, it's okay to put inside the object, but not too much in terms of for clarity of the drawing. So I have diameter 4 like that. Okay, maybe I can drag it at this position. Okay, alright, the next thing is about as I mentioned about the supporting ribs to hold the motor. I have don't have to put detailed dimension, at least I can show what is the cutout of the supporting rib. We have a half circle there where we will mount the DC motor. So here I can give, since it's not showing this shape, is actually, as you can see here, the shape of cutout is a kind part of circle. So I can do a section, I can do a remove section. Under drawing we have remove section again. I do remove section, I can select this line and this line. So we have level where we will put the remove section. I go for that middle point, then I just simply click OK. Then I bring my remove section to this position, and now I have a cross-sectional view of this sectioning of the supporting rib. Right, so I don't have to give detail what will be the length, the width. The only thing that I need is about this diameter. So only for assembly and fitting, because we need to mount the motor at the at this what we call it, the supporting rib. Since the motor the diameter is 18, so we have a radius 9. I can go like this, and maybe I can go like this to put the dimension 9. Okay, there is a dimension radius 9 for this circular cutout. Okay, so I go for, under value here, I go for no decimal point. Okay, put to this location. Alright, and so this is a remove section. For the other side, I don't have to do the remove section again like what I've done here. So the only thing that I need to show is about what will be the length from here to here. Alright, to do that I do smart dimension, then I will select this line. Actually I can select this line. Okay, from this line to this location. Sometimes it's allowed for you to put dimension inside in terms of clarity of the drawing, right, but not too much. So I put no decimal point for this, so at least we know the distance from this supporting rib to this location, right? Okay, here about the, we have a cut through hole here where we will mount the power button. Okay, I can do dimension from here to here. So I will put here dimension 14 at this location. Okay, and no decimal point, no decimal point. And about this total length, I can shift it to this location, right, to this location. Okay, now I have give the dimension of this hole. And another thing is about, we have a slot here where we have a PCB will be mounted into the slot, and the PCB have USB port, and I need to give a dimension what will be this slot here. Okay, to do dimension for this slot, I will do the auxiliary view of this slot here. To do extension view, I can do it like this. Under drawing we have section. What I will do here, I will do section view. I'm not doing vertical or this one. I will go for this one, auxiliary section line. So I will select from this middle point, from this middle point to this middle point. Then I click OK. Then I simply click OK. Then I will make a this one we have, it's kind of like we looking from this view, we have this cross-sectional view, but the cutting section is kind of like a full section. Let me click OK first. If I select this cutting section line, I click at it, this cutting line, I edit cutting line, and I click at edit sketch, and then I select the line. I'm not adding more line, I just press escape and I select the line here. I make it shorter up until to this position, I simply click OK. And also about this section here, I make it up until here, and this one I make it longer up until this position. Right, if I click OK, as you can see now, if I exit, we have kind like remove section. So this is arrow of looking from this direction. So here when we looking here, we looking at this direction, then I can see the normal view, perpendicular view, for me to do dimension for this slot, for the USB port to be fitted into this slot. So I can do smart dimension from here, this point to this one. So this will be 4.5. I can go like this, and also I can give dimension from this point to this point. I make a line dimension like this, and I go this one for 3. This one is no decimal point. Then I click OK. Now I have the dimension. Okay, another thing that I found out here, this cutting line here, this cutting line, I need to, since the viewing direction is to this direction, I need to click flip direction, so it will goes to this viewing direction. And now my section view here, it goes to this orientation. Right, so I need to adjust. So I already put the dimension of the length here, and hold on, I need to adjust. So this will be the width and length of the slot. So it is meant for the PCB with the USB port fitted into the slot. Alright. Okay, the label here I can change it. Instead of H, I can go for, make sure it's capital letter X. I simply click OK, and now I have this section view for this to show these pictures. Okay. And another thing I found out that since we have section at X, so this kind of like remove section, I can bring the title here. I don't want it to be overlap with the title block. And about this title, I need to change it. Make sure the capital letter, and make sure the text height is 4. Okay. Okay, now I've done this, showing the size for this slot. Okay, the next one will be the location of this pin. So I will do smart dimension, and I will not select the center mark there. Just simply select the circle and this edge, and I goes here, and the dimension is 10. Right. Okay, the last thing to show is about this one. I need to show, since we will mount the PCB into the slot, at least we must show what is the length of the slot, not the outer length. What I mean is the inner edge from here to here, since this length will be the length of the PCB. I cannot put it here, kind of like I don't have enough space, and even at this position, sometimes like I have mentioned before, it's allowed to put the dimension inside the object, but not too much for clarity of the drawing. Okay, now I have length 39. The length 39 is the length of the PCB. Alright, another thing is about the PCB, we have thickness. I must give what will be the thickness. from here to here, so I must give this dimension as well, since this will be the size of the PCB. Alright, let me check again. Okay, I believe I have okay, one thing about this X, so this is a letter X. I can adjust the letter X at this position. Okay, I need to position this front view here to make it to the center of this drawing. Okay, at least all this views is at the correct position. Alright, the next thing is about the dimension of this internal thread. I need to show it, since this is important features to be shown, since we need to mount the M1.5 screws into this internal thread at the back there. So I need to put dimension. If I go for annotation smart dimension, I cannot point to the, we have features in internal thread, it cannot point to the circle or the curve. If I select this, one, I cannot point to make a radial dimension. But if I select this curve, this is not the internal thread, this is diameter, this is the inner diameter of this pin, so I cannot do that. Alright, in order to do this, to give a internal thread dimension, under annotation here, we have a option called hole call out. I click at hole call out, it will detect this circle here, so I can do dimension here, and I can put the dimension here, but I will not go for radius 0.75. so under the dimension text, I go for metric thread. Make sure capital letter M. Hold on, make sure it is M 1.5. 1.5 is the major diameter. Okay, then so this can show that this thing is a metric thread. The major diameter is 1.5, so it means that the screw M1.5 will be fitted onto this internal thread. Alright. Okay, one more thing before I forgot, about the dimension of this. At the end here, this is since the shape of this rear casing is the upper part here is cylindrical shape, so I need to put diameter symbol before this dimension text 50. So here at the dimension text here, so I will click at diameter symbol, so it shows that this is a cylindrical shape. Alright, another thing is that about the section lines, the hatching, it's not using the, it's using the material cross hatch, so I will use parallel lines, and I will go for 3, and angle is 45 degree, and same goes here. So I need to select this one and also select this one. I'm not using material cross hatch, so I will use parallel lines, and density is 3 and 45 degree. Okay, let me save my file again. And okay, another thing is about if you look at this title block, the scale is 1:1. I already changed the scale to 1:1 since this front view, when I drag this front view, the scale is 1:1, so I have already changed it to 1:1, so be aware of this scale. Okay, hold on, something is not updating here about this one. I have to click this. Sometimes it happens like this. This one is already supposed to be parallel lines. Okay, one final things that I forgot to put is this. We have at the back here, since this is the cylindrical unit of this rear casing, at the back there we have a L key shape, where this L key will be fitted into the L slot of the dust container, since the dust container will be mounted at this position, and this L key will lock, snap fit lock to the L slot of that dust container. So it's very important to show the features of this L key, to show the dimension of this L key. Alright, to do this, I will go here, the view palette. Yeah? At the view palette, I can go for the, here we have a back view. So I will drag this back view. As you can see, it kind of like automatically align with the front casing. So I will go to this position, and let me click OK first. And now I have the back view. Alright, about this back view, since this is not a section view, I have to, hold on, I have to, I select this viewport, make sure that one thing is to make the tangent edge remove, and also this one I have to go for show hidden line. Okay, since at the front casing I have kind of like give really detailed dimension, and at the back I don't need to repeat the dimension. The only thing that I need is only this L key shapes. Sometimes it's, let's say that I don't want to show the whole view. It's okay to do this in engineering drawing, since what I need to show only for this back view is only the L key shape. I can do it like this. If I go for a sketch and I will do a rectangular, what I need is only this zone only, where we focus only on the L key. I will create a rectangle here. Then under drawing we have another kind like we call crop view. Crop view, then automatically it will crop only to the area that we want, alright, based on the sketch that I've done, the rectangle. Right, it kind of like okay, here I can put extra notes. Sometimes when people who read the drawing, he couldn't understand what is this. At least we could put some notes here under notation. We put some notes, so this would be, make sure everything is in capital letter. Say that this is back view. This is back view, and key features. What we can say, we can type this is back view, and we can type this is key feature of this at the end of this nozzle of rear casing. Okay, make sure that the text, when you double click at it, the height is, since this is a footnote for this view, I put it about 4 millimeter. Okay, another thing is to the alignment of this text is center like this. Right, so I drag it here, and now so it's already stated back view key feature. And okay, we have back view key, we must have S here, key features. Alright, then I will do, here I can do detail dimension. Right, I can go for here the thickness of the L key. Okay, I do smart dimension from here to this line. Okay, it's stated 2.03. Actually the value is 2, it's not 2.03, since the way I've done this key in my earlier video, I use wrap command, so it will be the true value is 2. Here 2.03, I can replace dimension text here, I can type it as 2. So because the 2 is a value of the thickness of this L key. Another thing is about here, I can go for this one is 2, and I can go for the length. Okay, the length is 13.37. as I have mentioned, the true value is 13. Right, since the way that I've done to make this key is by using wrap command, so that will be the true value. The 13 and 2 will be the size of this key feature of this at the end of this rear casing. Alright, I save my file again. Okay, one final thing is about the scale of this drawing. Since from the beginning when I drag this front casing, everything the scale is 1:1. So here I need to edit this title block. The scale must be 1:1. Okay, I believe that's all for the detailed drawing of this rear casing. Alhamdulillah, I have completed the detailed drawing of this rear casing. I will do the detailed drawing for the front casing, but I will not show you in this video because I believe by watching this video of how I have done the detailed drawing of this rear casing complete with the important dimensions only, you can learn something from it and you can implement it to do the detailed drawing for the front casing, since the front casing is kind of like similar like rear casing. The only thing is that the front casing is a mirrored representation. Okay, about the other parts as shown here, inshallah in the next video I will do the detailed drawing of all the other non-standard parts, like the impeller. We have the rear cap, we have the dust container valve, and crevice nozzle. Okay, about the HEPA filter, I found out that this HEPA filter may be a standard component. Because sometimes in industry, design and manufacturing industry, like this mini vacuum cleaner, not all the parts they do on their own. So it means that for this HEPA filter, they have a vendors who will do it for them. So it means the vendor will do and design and manufacture the HEPA filter, not this company who design and manufacture this mini vacuum cleaner. So it means that this company will simply order the HEPA filter from the vendors. Okay, if this is the case, it means that this HEPA filter will be a standard part. So if this HEPA filter is a standard part, we will not do the detailed drawing for this HEPA filter. Alright. Okay, inshallah I will see you in the next video, but before that, please do appreciate my effort of doing this video tutorials to you guys by clicking like, subscribe and promote my video to your friends. Assalamualaikum warahmatullahi